is week 3 of geometry, so I'm super excited. And today, I'm gonna wait a little bit for maybe a few more people. Okay. Today, we're going to be going through mostly quadrilaterals. So, but first, let's get into our weekly icebreaker. I want to first ask how you guys are doing on the Baby Yoda scale today. I'd say I'm like a 9. I'm doing good. And I also want to know if you guys have song recommendations, because I love making Spotify playlists, and it'd be cool to get some new music on my radar, you know? All kinds of vibes. Without me, I listen to anything. But kind of chill. Ooh. Is fight song this is my fight song, you know? Oh, okay.
Staple that shit.
Sorry, I didn't hear whoever just said something, but okay. So I think we should get into it. I love sad songs. I like Gracie Abrams is my favorite artist, or Phoebe Bridgers. Anyways, okay, so little stuff we're going to be going through today. We're going to be talking about a lot of quadrilaterals, and there's a bunch of different kinds of quadrilaterals. There are parallelograms, rectangles, squares, trapezoids, all of these. And we're going through how to find the area of those. And I, again, don't think we're going to be getting to construction, but I will try. I wrote this little warning sign because I think we're going to need to know some basic Pythagorean theorem stuff. Just for a couple of the proofs. So I'm just going to basically run through it real quick, just in case you haven't heard of it. So if we have a right triangle, the Pythagorean theorem tells us that the longest side of the right triangle, which is the side opposite of the right angle, it's called the hypotenuse, and it tells us that this length, let's call these sides A, B, and C. It tells us that C squared equals A squared plus B squared. And we're going to need to know that for a couple of proofs. But yeah, if that trips you up, then that's all right, and we can work through it together. Okay, let's get into our first thing. So we're going to be covering quadrilaterals. I think I touched on this last week. And in quadrilateral, the definition is it is a polygon with 4 sides, 4 vertices, and 4 angles. And a vertice is where the 2 sides meet. So it's this point right here where the 2 sides meet. And on a 3-dimensional shape, it would be where the 3 sides meet. Cool. And here on the left, we have a convex. Yes, a convex polygon. And on the right, we have a concave polygon. Concave is when something bends in. I think magnifying glasses are concaved, so they magnify things, but it could be the other way around. Okay, so real quick, we can actually figure out how many angles are in a quadrilateral by using what we know about triangles. So does everyone, you can all tell me how many angles are in a triangle. There's 180 of them. So what we're going to do with this shape, basically on the right, is we're going to figure out what this angle is but we're going to use a little triangle action to help that. So here's a little strategy. We're going to split this from A to C, draw a straight line. Thing about what we know is that 2 triangles, which would both have 180 degrees total, that means between this angle, this angle, this angle, there are 180 degrees, and between this angle, this angle, this angle, there are 180 degrees. So the total amount of angles in a quadrilateral would be 180 plus 180 which would equal 360 degrees. And this works for any quadrilateral. So I have a practice problem that says, use the same kind of strategy to prove that it would also work for a convex quadrilateral. So that's not, oh, it actually worked. I thought it was going to be a bad drawing, but you know, let's label this A, B. No, that B should not be there. A, B, C, D. Where do you think we could fit a couple triangles in, guys? Triangles are like the key to solving literally everything in geometry. They're so nice. But yeah, so the way to prove that the interior angles of a convex quadrilateral add to 360 is we could draw a line right here from B to D and say now we have two triangles. Both have degrees of 180, and then the sum of them would be 360 degrees. So let's get into our first classification of quadrilaterals, which is a trapezoid. You've probably heard of these basic shapes. A trapezoid is a quadrilateral in which two of the sides are parallel. On this quadrilateral, we can see that the parallel sides, so WX and ZY, are called the bases of the trapezoid, and the sides WZ and XY are called the legs of a trapezoid. This little dashed line here is called the median, and it comes in really helpful when we're trying to solve for things like area. So I have a practice problem here that I want you guys to try out. Says the bases PQ and SR of a trapezoid, PQRS, have lengths of 5 and 9 respectively. They are also 8 units apart. So I want you guys to find the area of PQS and QRS. So those would be triangles. And then you can use that to find the total area of the trapezoid. And then from there, we can kind of see some patterns that we can maybe use to determine a general formula for the area of a trapezoid. So I want to say it always, always, always helps to draw out things when you're not really given a clear picture of where everything goes. So I would say draw it out. Use what you know about triangle areas. I'm going to give you guys like 5 minutes. And yeah, see if you can figure out a general formula, because that's really cool. Being able to find the way to solve the area for anything. Okay. I'm going to work along with you. Hey, so I think a couple new people have joined, and just to catch you guys up, I'm gonna draw out what we're looking at here because visualizing is literally so helpful every single time. Okay, so let's say that is definitely not a trapezoid. Whoa. Let's say I have this trapezoid right here, and it tells us that PQ and SR are bases of it, and it tells us that SR is 5, let's say 5 inches. Oops, why did I write that? And PQ is 9 inches. So by using like these steps and following through this proof for this problem, you can determine the general formula for an area of a trapezoid. And the first step is to find the area of these two triangles that I just separated out there. Okay, I'll check back in like 2 minutes. Cool. Okay, so did anyone here want to share what they got for part A, area of the triangles? How about Peony? Do you have any thoughts on how to find the area of these two triangles?
Not yet. I'm still solving it.
Okay, that's fine. Do you guys all need a little more time? I'll give you guys like 2 more minutes. Thanks for that. Okay, so I think I'm gonna walk us through this together. And if you guys have any thoughts, please shout them out or send them in the chat. Okay, so we're given some information. We know that this is a trapezoid, PQRS. And we know that the lengths of the two sides are 5 and 9, the two bases. We also know that the two bases are 8 units apart. So this is a really getting like a messy drawing. So, okay. We know that this distance right here is going to be around 8 units. And from that, we can find the area of these two triangles, QRS and PRQ. I think I put 2 R's. Either that or my handwriting was just really something. Okay, so we all know the area of a triangle equals 1/2 base times height. So let's look at triangle QRS first. If we can separate it from the rest of the trapezoid, we know this side is 5, and we also know something. We know that the base, or the distance from the top to the bottom, is 8, because it tells us that the bases are 8 units apart. So for triangle QRS, the area would be 1/2 times 5 times 8, which would be 20 units squared. Another cool thing, the area notation, sometimes you can write like this, like 2 little brackets can symbolize area. Okay, so I'm gonna erase the steps for getting to that answer. Oh wait, I don't want to erase the answer though. I think I did it again. Sorry. Okay, so we know the area of QRS equals 20. And then following the same steps, can anyone tell me what they got for the area of PQR? You can hit it in the chat. Welcome everyone new. Good to see you guys. Okay, so basically same process to go about solving for the second triangle. It's just we know the base is 9 and we know the height, which would also be the same here, is 8. So we know that triangle PQR equals 1/2 times base, which is 9, times height, which is 8, which would be equal to 4 times 9, which is 36. And then from that, we can find the area of the whole trapezoid. So yeah, I got one answer in the chat. Thank you. Thank you for the correct answer. I'm sure you had a wonderful thought process. So to find the area of the whole trapezoid, we have everything we need, because the whole trapezoid is just the sum of the 2 triangles. So this trapezoid would be 20 plus 36, which is equal to 56, let's say, units squared. Okay, so it might not be that obvious of a pattern, but if you have any wild thoughts of how to come up with that answer, and how, you know, the lengths of the bases relate to the height and the area, actually they're going to be like really smart answers. So the crazy ones are always the smart answers. What I'm looking for here is, if you notice, the number 7 is kind of in between 5 and 9. And we know the height is 8. And we also know that 7 times 8 is equal to 56, which was our area. And that brings us to the general formula for the area of a trapezoid, as well as something valuable we learned from that, which is the mid-segment theorem. I call it a median. Other people call it mid-segments. Okay, so the area of a trapezoid is going to be height times length of median, which is also equal to base 1 plus base 2 divided by 2. So I think I have a practice problem here. I have 2 right here. The one on the left is going to be really straightforward, find the area. The one on the right is going to be kind of reverse engineering that process. And so I want you guys to use this formula when we just derived and see what you can do with those 2 problems. You can choose to do one or both, or, you know, just the hard one, just the easy one. Yeah, I'll give you guys a couple minutes. Please send your answers in the chat. And thanks. Okay, I'm gonna call on one of you guys. Hey, Daniel. Oh wait, I forgot. Does your mic still not work? Well, that's all right. Timothy, do you think you could walk us through part A? Even any start is really helpful. All right, that's a good. Does anyone want to volunteer? Hey, Peony, do you want to explain part A?
Yeah, sure. So I did 1/2
Mm-hmm.
times 44 plus 24.
Gorgeous. Which
And then I multiply it by 18.
cool. And what did you get for a final answer?
I got 612.
Okay, yeah, same. Cool. Did you do part B?
I just started part B.
Okay, that's all good. Has anyone here finished part B? All right, I'll give you guys like 2 minutes. I got a really similar answer, Peony. I got B equals 9. So I could have made an arithmetic error. Should we go through it and see where the discrepancy was? Because it's probably simple math. Okay, so we're looking at, if we have this trapezoid, we know its area is 96. And let's call this base X. And we know the longer base is 6 units longer than the short one. So let's call it X plus 6. Okay, so we know from the formula, oh, sorry. We also know that the height is 8. So we know from the formula that the area, which is 96, is equal to the height, which is 8, times base 1 plus base 2 over 2, which now we have x plus 6 as the two bases. By the way, I hope you guys noticed that I used like the geometric slide theme. I thought that was kind of cool. That's my favorite slideshow theme. I use it even not for geometry. Okay, so what we have is 96 equals 8 times, we can add the two x's, 2x plus 6 over 2. From there, we can divide out a 2. So it's just x plus 6. Oops. I missed the 9 on that 96. Okay. And we can multiply that out. So let's say 96 equals 8x plus. So I don't know if you guys have learned algebra, but this is kind of like a distributive property. So when you multiply two things within parentheses that are added by something outside of it, you multiply by each one of those, and then you add the two things. So that would be 96 equals 8x plus 48. And then if we could subtract the Actually, I think I found my error in solving this. When I solved this, I got 24 over here for some reason. So yeah, I think you were right. So if we subtract 48 from both sides, then over here, pretty sure we also get 48 equals 8x, and x equals, wait, I did something wrong, I feel like. Is 8 times 6 48? Let me get my calculator up. Right? And then what's 96 minus 48? That is 48. Cool. And 48 divided by 8 would be 6. Okay. So yeah, so basically we're looking at a trapezoid with one base length 6 and one base length 6 plus 6, which is equal to 12, and then a height of 8. Cool. Thanks guys for following along. I hope I'm not going too fast. Please ask questions if you're a little confused. Okay, let's move on. These are really basic. You don't really have to know what they are. It's just like an isosceles triangle. Okay, step 2, what did I do? Well, my work is like too messy, so let that be a lesson. Okay, step 2, was that me multiplying out the 8? Oh, you're right. Oops, what did I just do? Sorry for my lock screen guys. Okay. Okay, so I think what Aaron is saying is that here, when I divided out the 2, like right here, I should have gotten 8 times x plus 3, because 6 divided by 3 is 3. So then I would multiply out the 8, that would be 8x plus 24, and then subtract 24 from both sides. I think it would be something like 72 equals 8x, x equals 9. I think that's right. Yeah, thanks, Aaron. Thanks for checking my mistake. You guys are really good. Okay, so final answer. So this would be a 9, and this would be a 9 plus 6, which is 15. Cool. All right. So isosceles trapezoids, they have equal sides on the opposite sides and equal angles where the bases meet. And you don't really need to know this. So this is a kind of a weird thing. A lot of different people have disputed what it means to be a trapezoid. So the definition says a trapezoid is a shape with one pair of parallel sides. And some people take that to mean it's only one. So a trapezoid is a quadrilateral with only one pair of parallel sides. But some people think that actually means that a trapezoid is something with one or more pairs of parallel sides. So they would think that this is actually a trapezoid. I don't know. I kind of agree with the first definition, but whatever floats your boat. I'm not going to dispute it. And okay, so I'm going to take a little short intermission just for some cool geometry stuff. Basically, if you take any triangle, like any triangle at all, and then you use its sides to draw equilateral triangles, and then join the centers of those equilateral triangles, the triangle that you will form is also an equilateral triangle. And that's called Napoleon's triangle. And it's attributed to Napoleon, the French guy, but there's nothing to like really prove that he was the one to discover it. So I don't know if he was really the mathematician or what was going on. Okay, so this shape here is commonly more recognized as a parallelogram probably. And a parallelogram, the formal definition is a quadrilateral with two pairs of opposite parallel sides. And these opposite parallel sides are also equal length. So AB would be equal length to DC, and AD would be equal length to BC. And yeah, they're parallel to the opposite side. Another cool thing you can see, these lines that go from corner to corner, we call them diagonals. And they just go diagonally through the shape. And when we have a parallelogram, its diagonals bisect each other, which means that these two kind of sections of line are the same length. Yeah. All right. That's also what I wrote here. So yeah, this fact is going to come in later. It's actually not true for parallelograms, but for the next shape that we're going to cover. Okay, so a way to prove that the diagonals of a parallelogram bisect each other is, again, using triangles and triangle congruence. So say we have this parallelogram. We know that the opposite sides of which are equal, right? On top of that, we know that they share sides with each other. So from here, we know that like all four of these triangles are congruent. And because of that, we know that, we know that these side lengths are going to be the same. We know that these side lengths are going to be the same. So that's how we know that the diagonals bisect each other where they intersect. Okay, so the area of a parallelogram, I always thought it was really cool. What you do is you kind of slice off the edge and then you move it over. So it just turns into a perfect rectangle, which is it's so visually nice to look at. If you take this part right here and then you just splice it right over to the right side, and it's really kind of easy to see that a parallelogram is kind of just a rectangle, but chopped in a weird way. And from that, we know that the area formula is just simply base times height, with the height being like, this is not the height just is like connecting the two lines. Okay, so I have a practice problem. I think we should work through this one together. If you have questions following along, please ask. Okay, so let's say we have a quadrilateral work, and we know that WO is equal to RK. We know that WO is parallel to RK. So what we're trying to prove is that work is a parallelogram. So a couple of things when you're trying to prove that something is something, you always have to look at the definition. In this case, it would be a parallelogram, and look at what proves that a parallelogram is a parallelogram. And in this case, it would be two pairs of opposite parallel sides. So let's draw it out. I'm going to draw it kind of assuming that it is a parallelogram, WORK. So what do we know? We're given that WO is parallel to RK, and we're given that WO is the same length as RK. Okay, so from here, what do we have? I always see where I can draw triangles and where I can make things fit, and just where we can use what we know. So here I see an opportunity to go from R to O. And because we know that WO and RK are parallel, we know that this angle would be equal to this angle because they're opposite interior angles. From here, because we know that this side length is equal to this side length and this side is shared, we actually know that these two triangles, WOR and ROK, are congruent. Oops, I wrote the wrong symbol. My bad. So we need to prove that this is a parallelogram, right? So we need to prove that it has two pairs of opposite parallel sides. And using what we know about parallel sides, if these sides were to be parallel, then the angles like, if we were to like cross-section it like this way, these angles would be the same. And what we have from these two congruent triangles is that those angles are in fact the same. So we know that RW equals KO. All right, so, okay, let's move on to rhombuses. So a rhombus, you're probably gonna look at that and be like, that's literally a parallelogram, and it is, because all rhombuses are parallelograms. Rhombus is formally defined as just a quadrilateral with 4 equal sides. And, you know, it kind of looks a little like a wonky diamond here, but, you know, when you think quadrilateral, 4 equal sides, automatically you think square. And if you've heard like a square is a rectangle, but a rectangle is not a square, that's true for this too. A square is a rhombus because it has 4 equal sides, but a rhombus is not necessarily always a square. Okay, cool. So Oh yeah, further in this little definition chain, kind of, every rhombus is a parallelogram. And yeah, you can kind of see that visually. So because every rhombus is a parallelogram, we know everything that is true about parallelograms is also true about rhombuses. That includes area formulas and things about diagonals. The thing about rhombuses, though, is whenever we draw the diagonals of a rhombus, they always meet at a 90-degree angle. All right, so I have a practice problem. I'm going to draw out the first couple of steps and see if you can solve the rest. This actually probably shouldn't be too hard. This is what I was talking about, the problem that involved the Pythagorean theorem. So let's say, whoa, that is not a rhombus. Well, okay, I'll work with what I got. Let's say this is our rhombus. And it has diagonals PR, which is equal to 6. Pretend that these are different lengths. And QS, which is equal to 12. Actually, let me redraw that better because that is actually not a good. Okay. So let's say this is PR. Say this is QS. So a couple of things we know about the diagonals of a rhombus is that they bisect each other. So we know that line is equal to that line, and we know that these lines are equal to these lines. We also know that they meet at a 90-degree angle. So given what you know about the lengths, try to find the area using probably the Pythagorean theorem and the perimeter using also the Pythagorean theorem. I'll just write that here. And yeah, should we make it a speed competition? See who can get the answer first. And you get, if I was in person, I'd give you like candy or something, but I'll Venmo you like 10 cents. Okay, I'll give you guys a couple minutes. Okay, guys, we have like a 3-way tie for winner. Thank you to Daniel, Grace, and Aaron for all being exceptional mathematicians. Yeah, would any of you guys love to share? Not love. Well, I guess you can love it. Would any of you guys like to share how you got to your answers? How about Aaron? Can we hear from you? Well, that's all right. Okay, so let's all walk through this together. And Grace, do you want to share?
Sure.
Yay.
So for P and R, if you
Yeah.
cut it in half, it's 3 on one side. And I
Yeah.
use the triangle method. So if you do Q and S, it cut that in half, it's 6. And then so 6 times 3 is 18, and 18 divided by 2 is 9. And then since there are 4 triangles, I did 9 times 4.
Yeah, that's perfect. 9 times 4 is 36. Okay, cool. So yeah, you actually use that all these triangles are congruent triangles, which we can prove by side angle side, here, here, and then the right angle. But yeah, great job. Thanks so much. And thanks, Erin. For the perimeter, we would use what we have for the Pythagorean theorem, which tells us that the side length here, which would be equal to the square root of 6 squared plus 3 squared, which is also equal to the square root of 36 plus 9, which is, help me with the math, 45. I don't think that resolves out exactly. So the perimeter would be 4 times root 45. And I think, yeah, Aaron and Daniel both simplified that for us. Should be 12 root 5. That seems right, which is also equal to like 29.39. So thanks, guys. Okay. So here's a theorem. The diagonals, okay, sorry, we went over this. I think my slides are out of order. Okay. So I have another practice problem here. It's just like basic areas and stuff, but you're actually gonna have to use the diagonals again. So yeah, let me draw out W, X, Y, Z. C is an optional challenge. When I first looked at like part C, I was so like, how am I supposed to find that? And I like tried to look up the answer and I'm still a little lost. So if you guys can figure that out, then I'm really, really impressed. Okay. I'll give you guys a couple minutes. Oops, not 99, 96. Cool. So I'm going to keep us moving because there's some stuff like the promised Minecraft. What's it called? Like tour? Yeah. Okay. So does anybody want to share if they have any thoughts for parts A and B or even C? It's all good if you don't. All right. Okay. So let's work through this together. So to find xz, that would be this line crossing through right in the middle right here. And what we know about the diagonals, right, is that they bisect each other. So we know that because this total length WY was 96, we know that each side, let's call this middle point right here, O. We know that WO would be 96 divided by 2, which is 48. Oh, I think I tried to write 488. And from here, we can use the Pythagorean theorem to figure out the length of XO. And we can do this by saying, okay, we can do this by saying 50 squared equals 48 squared plus XO squared. I'm not actually going to go through and do all the math for that because, you know, trying to conserve time. And the way to find the answer to XZ would just be to double that. So wait, and then yeah, XO times 2 would be XZ. So it's going to be a pretty big number, I feel like, but yeah. Okay, and then to find the area of WXYZ, does anybody have any thoughts? You can raise your hand if you want to share. All right, that's all good, that's all good. So same process as we used in the last practice problem. Basically, if we take, just like Grace said, because we have 4 equal triangles, we take the base, which here would be XO, right? And well, I guess here the base would be 48 and XO would be the height, and divided by 2, we'd get the area of one of these triangles, and then you just multiply that by 4. So this would be 4 times 48 times XO divided by 2. My parentheses are really weird for that, but yeah. And the distance between WX and YZ, I really still have no idea. I think solving for this side would be pretty easy, but I don't think that's what the problem means by finding the distance, because the distance usually means like the shortest path to each line. So I think it would be more like that. And I really have no idea how to solve that. So if you guys know how to do that, then really good for you. And you should share that with me because I'm at kind of a loss. Okay, I'm going to speed run through rectangles because you guys have heard of these before. Quadrilateral with 2 pairs of 2 equal sides and 4 equal angles. It turns out that when a quadrilateral has 4 equal angles, they all end up being 90 degrees, right? That's just like because 360 divided by 4 is 90. Okay, cool. And yeah, a rectangle has 2 opposite equal pairs of sides. Rectangle is also a parallelogram because if you picture these as like lines, right? And this is your parallel postulate, like this line is the one that cuts through the 2 pairs of parallel lines. Then we know this angle is equal here. So then like the alternate exterior angles are equal, which means that these lines are parallel. Okay, cool. Same process works for these sides. Okay, I just did that. Sorry, it just says prove all rectangles are parallelograms. Okay, cool. So this is a really complicated problem, and I don't think we have time for it. And I just want to introduce it. So it says, prove the quadrilateral formed by connecting the midpoints of the sides of a rhombus is a rectangle. So say we're given this rhombus, and then we take all these midpoints and we connect them. And then the idea is to prove that this inner shape is a rectangle. And the way we do that is to actually prove like this. These triangles are congruent, these triangles are congruent, things with angles and that stuff. And I just want to share a quick story. This was the hardest problem I ever faced in my geometry career, and I still don't know how to do it. I've scoured the internet and I actually haven't found like a good proof of it. It says, prove the quadrilateral formed by connecting the midpoints of the sides of a quadrilateral is a parallelogram. And I got this question on an exam. So I was like fully mentally zonked. And I was like, oh my God, how do I do this? I actually didn't think that I could do it. And by the end, I had rewritten that so many times, that proof. And I was just making things up. And, you know, I'm pretty sure I got 2 out of 8 points for that problem, but that's all good. So it's basically asking to prove that the midpoints of literally any quadrilateral will always form a parallelogram. So I hope you guys get thinking about that one because I still don't know. All right. Okay. I have a really quick rectangle problem, just areas and perimeter and that stuff. I'm going to give you guys like 2 seconds. What's on the next slide? Okay, yeah, 2 seconds, finish this up. Okay, Aaron, thank you for the idea. Okay, so connect the diagonals. Would you mean the diagonals of like the big quadrilateral or like the inner parallelogram? So the diagonals here, those could be really helpful. I think like the proofs that I looked up on the internet. Yeah. The proofs that I looked up on the internet, they all started with that first step, like connect the diagonals. But then I didn't understand what followed that. Aaron, if you can figure this out by next week, you should explain it to me. I'll give you a chance to like be the teacher, you know? Okay. So real quick, rectangle problem. This is really elementary stuff. You guys all know the deal. POST, 8 times 12, the length of PS, that's gonna be a little harder. So the length of PS, we know this is a right triangle, so it's just Pythagorean theorem again. So it'd be square root of 8 squared plus 12 squared. And the perimeter of this rectangle would be 2 times 12 plus 2 times 8. I'm sure you guys do this or have done this in like your 3rd grade math class, so should be all good there. Let's get into our final quadrilateral, which is the square. Very, very, I would say overrated shape, not gonna lie, but you know, it has its ups. So a quadrilateral is a square is a quadrilateral with 4 equal sides and 4 equal angles. And yeah, you guys know what it looks like. So real quick area and perimeter formulas. If you only have one side length, then the side is like the area is just going to be equal to its squared. So it's just equal to side length squared. And, you know, it's called squared because it's the area of a square. All right. Okay. So these problems are actually kind of cool. This one is really interesting. There's a really interesting thing that you can find out between the ratio of like squares. That is not a square, but yeah, squares formed like this. It's a really cool ratio. You should think about it, but no time right now. Okay, so here's just like a brief overview. I know I talked a lot about like how quadrilaterals are classified and how weird it is and how the definitions overlap, but yeah, so here's a little quick visual.